Swapping the hot and neutral wires can create a short circuit, allowing a large amount of current to flow uncontrollably. This can lead to overheating of wires, electrical components, and a fire. The swapped hot wire, carrying the full load current, would overheat the panel, meter, and other components. Insulation between the hot and neutral wires may fail due to overheating, creating an arc fault, releasing heat and sparks that could ignite a fire. The first fire may have been caused by a short circuit or arc fault, resulting in minimal damage, but the utility company's repair may not have fully resolved the underlying issue. The second fire could have been due to smoldering insulation from the initial overheating, which damaged the insulation, causing it to smolder and eventually catch fire. The smoldering insulation may have transferred heat to other materials, such as wood, causing them to ignite. Even with inspections, there may have been ongoing electrical problems related to the swapped wiring. The utility company may not have thoroughly inspected the meter and surrounding wiring. The electrical inspector may have overlooked the swapped wiring during their inspection. The fire inspector may have underestimated the potential for smoldering insulation to cause a delayed fire. It is recommended to take the following actions. Firstly, have a qualified electrician conduct a comprehensive inspection of the entire electrical system, including the meter, panel, and wiring. Secondly, ensure that all wiring complies with electrical codes and that the hot, neutral, and ground wires are connected correctly. Thirdly, any damaged insulation should be replaced immediately. Fourthly, use a thermal imaging camera or other tools to detect any hotspots or areas of excessive heat. Finally, install surge protectors to prevent electrical voltage spikes from damaging electrical components. If hot and neutral wires are swapped, several things can occur. The immediate and most dangerous consequence is the creation of a short circuit. In a properly wired circuit, electricity flows from the hot wire through the appliance or device and returns to the source through the neutral wire. When the hot and neutral wires are swapped, the electricity bypasses the intended load and flows directly back to the source, creating a path of very low resistance. This results in a massive surge of current far exceeding the capacity of the wires and circuit breakers. The excessive current generates a significant amount of heat. Wires, especially those not designed for such high amperage, begin to overheat rapidly. This overheating can melt the wire insulation, leading to even more dangerous situations like arc faults and electrical fires. Electrical components like outlets, switches, and circuit breakers are also susceptible to overheating and failure under these conditions. Arc faults are another serious consequence. As the insulation in the wires melts or deteriorates due to overheating, the exposed wires can create an arc fault. An arc fault is a dangerous electrical discharge that occurs when electricity jumps from one conductor to another through the air. These arcs generate intense heat, reaching temperatures high enough to ignite nearby materials. Arc faults are a major cause of electrical fires. The initial damage from the swapped wires can remain hidden for some time. Even if a breaker trips and cuts off the power, the initial surge of current and overheating can cause latent damage to the wiring and insulation. This damage can weaken the insulation, making it more susceptible to future failures and increasing the risk of a fire later on. Smoldering is a dangerous process where material slowly burns without producing a visible flame. The swapped wires can cause the insulation around the wires to overheat to the point of smoldering. This smoldering can continue for hours, even after the power is shut off, and can eventually ignite surrounding materials, leading to a full-blown fire. The delay between the initial electrical event and the eventual fire can make it difficult to pinpoint the cause of the fire. The initial electrical surge can also damage appliances and electronic devices. The sudden and uncontrolled flow of electricity can overwhelm the sensitive components in these devices, causing them to fail or become damaged. This can lead to costly repairs or replacements. Grounding issues can also arise from swap wires. In a properly wired system, the ground wire provides a safe path for electricity to flow in the event of a fault, helping to prevent electrical shock and further damage. Swapping the hot and neutral wires can compromise the grounding system, making it less effective and increasing the risk of electrical shock. Electrical panels and circuit breakers are designed to protect circuits from overcurrents. However, Swapping the wires can sometimes bypass these safety mechanisms, especially if the neutral wire is not properly grounded. This can prevent the circuit breaker from tripping, allowing the overcurrent to continue flowing and exacerbating the damage. Older wiring is more vulnerable to the effects of swapped wires. The insulation on older wires may be more brittle and prone to damage, making them more susceptible to overheating and arc faults. The connections in older electrical panels and outlets may also be looser and more prone to failure. The cumulative effect of these issues can significantly increase the risk of a fire. The swapped wires can also create a shock hazard. If someone comes into contact with a metal object that isn't properly energized due to the swapped wires, they could receive a serious electrical shock. This is especially dangerous in damp or wet environments. The incorrect wiring can also affect the operation of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock by monitoring the current flowing in the hot and neutral wires. If there is a difference in current, it indicates that some of the current is leaking to ground, and the GFCI will trip to cut off the power. Swapped wires can interfere with the GFCI's ability to detect these current differences, rendering it ineffective. It's essential to have a qualified electrician thoroughly inspect the electrical system to identify and correct any wiring errors. An electrician can use specialized tools and techniques to trace the wiring, test the connections, and ensure that everything is properly wired and grounded. It's also important to replace any damaged wiring or components to prevent future problems. Electrical safety inspections are crucial, especially after any electrical work has been performed. These inspections can help identify potential hazards and ensure that the electrical system is safe and up to code. It's also a good idea to install arc fault circuit interrupters, or RSIs. RSIs are designed to detect arc faults and quickly cut off the power, preventing electrical fires. These devices provide an extra layer of protection beyond traditional circuit breakers. Consider installing surge protectors to protect your appliances and electronics from power surges caused by wiring errors or other electrical problems. Surge protectors can help prevent damage to sensitive electronic components. It's important to educate yourself and others about electrical safety. Learn how to identify potential hazards, such as frayed wires or loose connections, and take steps to correct them. It's also important to teach children about electrical safety and keep them away from electrical outlets and appliances. The initial electrical event, such as the swapped wires, might not immediately cause a fire but can weaken the insulation or create a smoldering condition that ignites later. This delay makes it harder to trace the fire's origin back to the initial wiring error. Even if the utility company repairs the immediate issue that caused the breaker to trip, the underlying damage from the swapped wires might persist. This is especially true if the repair focuses only on the external connections and doesn't address the internal wiring within the house. A visual inspection alone might not be sufficient to detect all the potential problems caused by the swapped wires. Hidden damage within walls or behind electrical panels can go unnoticed, leading to a false sense of security. It's possible that the initial fire damaged the wiring or insulation in a way that created a new, independent fire hazard. For example, the heat from the first fire might have weakened the insulation on nearby wires, making them more susceptible to overheating and arcing. If flammable materials, like wood or paper, are located close to the damaged wiring, they can ignite more easily. The presence of these materials can significantly increase the risk of a fire. The age and condition of the electrical system can also play a role. Older homes with outdated wiring might be more vulnerable to the effects of swapped wires, as the insulation and connections might be more brittle and prone to failure. Inadequate grounding can exacerbate the problems caused by swapped wires. A properly grounded electrical system provides a safe path for fault currents to flow, helping to prevent electrical shock and fire. If the grounding is inadequate, the fault currents might flow through unintended paths, causing overheating and ignition. The type of insulation used in the wires can also affect the fire risk. Some types of insulation are more resistant to heat and fire than others. If the wiring uses a less fire-resistant insulation, it might be more likely to ignite in the event of a swapped wire situation. The local electrical codes and regulations can also influence the safety of the electrical system. If the wiring was not installed according to code, it might be more susceptible to problems like swapped wires and inadequate grounding. The lack of proper labeling can make it difficult to identify the wires and connections, increasing the risk of errors. Proper labeling is essential for safe and accurate electrical work. The use of non-standard wiring practices can also create hazards. If someone used unconventional methods or materials during the wiring process, it might be more difficult to troubleshoot and repair the system. The presence of moisture or humidity can also increase the risk of electrical problems. Moisture can corrode the wiring and connections, making them more susceptible to failure and increasing the risk of electrical shock. The electrical load on the circuit can also affect the fire risk. If the circuit is overloaded, it might overheat even with properly wired connections. Swapped wires can exacerbate this problem, leading to a higher risk of fire. The frequency of electrical inspections can also influence the safety of the system. Regular inspections can help identify potential problems before they become serious hazards. The quality of the electrical work is crucial for ensuring the safety and reliability of the system. Poor workmanship can lead to a variety of problems, including swapped wires, loose connections, and inadequate grounding. The accessibility of the wiring can also affect the ability to inspect and repair the system. If the wiring is hidden or difficult to reach, it might be more difficult to identify and correct problems. The presence of rodents or other pests can also damage the wiring, increasing the risk of electrical problems. Rodents can chew on the insulation, exposing the wires and creating a fire hazard. The proximity of flammable materials to the wiring can also affect the fire risk. If there are flammable materials, such as curtains or furniture, located close to the wiring, they can ignite more easily in the event of a swapped wire situation. The presence of dust and debris can also contribute to electrical problems. Dust can accumulate on the wiring and electrical components, trapping heat and increasing the risk of overheating. The use of extension cords and power strips can also create hazards. Overloading extension cords and power strips can cause them to overheat and potentially ignite a fire. The lack of smoke detectors can also increase the risk of fire-related injuries. Smoke detectors provide an early warning of a fire, giving people time to escape. The absence of ground fault circuit interrupters, or GFCIs, in wet areas can also increase the risk of electrical shock. GFCIs are designed to protect against electrical shock by monitoring the current flowing in the hot and neutral wires. The use of aluminum wiring can also create problems. Aluminum wiring is more prone to corrosion and overheating than copper wiring, especially when used with older connections. The improper installation of electrical boxes can also create hazards. Electrical boxes should be properly secured and sealed to prevent moisture and pests from entering. The use of undersized circuit breakers can also prevent them from tripping properly, allowing overcurrents to flow and potentially causing a fire. The lack of proper bonding can also create hazards. Bonding is the process of connecting all metal parts of the electrical system to ground, providing a safe path for fault currents to flow. The improper wiring of three-way switches can also create problems. Three-way switches are used to control a light from two different locations. If they are not wired correctly, they can create a short circuit or other electrical hazards. The use of multi-wire branch circuits can also create problems. Multi-wire branch circuits share a common neutral wire. If the neutral wire is disconnected or improperly wired, it can cause an overvoltage on one of the circuits, potentially damaging appliances and electronics. The improper use of cable staples can also damage the wiring. Cable staples should be used to secure the wiring to the studs or joists, but they should not be over-tightened or driven into the wiring. The lack of proper clearance around electrical equipment can also create hazards. Electrical equipment should have adequate clearance to allow for proper ventilation and access for maintenance and repairs. The use of flexible cords in place of permanent wiring can also create hazards. Flexible cords are not designed to be used as permanent wiring and can easily become damaged or overloaded. The improper use of wire connectors can also lead to loose connections and potential hazards. Wire connectors should be properly sized and installed to ensure a secure and reliable connection. The presence of exposed wiring can also create a shock hazard. All wiring should be properly insulated and protected to prevent accidental contact. The use of non-metallic sheath cable in exposed locations can also create problems. Non-metallic sheath cable is not designed to be used in exposed locations and can easily be damaged by physical contact. The improper support of cables can also lead to strain on the connections and potential hazards. Cables should be properly supported to prevent them from sagging or pulling on the connections. The use of liquid-tight flexible metal conduit, or LFMC, in wet locations can also create problems. LFMC is designed to be used in wet locations, but it must be properly installed and sealed to prevent moisture from entering. The lack of proper documentation can also make it difficult to troubleshoot and repair the electrical system. Proper documentation should include a wiring diagram and a list of all the electrical components.